Let us solve questions from set 3. So this is the first question. Language L equal to A comma B that accepts all strings that contains a substring BB. So we need to design DFA which recognizes L and validate this string. So first take language. So this language should be defined over input symbol A comma B. So we are writing all the possible strings which are having this BBAAB as substring. So here you can see BBAAB is a substring. So here string may start with either A or B. So these are few possibilities. So first up, we are constructing finite automata which accepts BB A B as substring, and string may start with A. So I'm taking self loop. So you can have any number of A's. If you take the first possibility or first possible string, you can see that. And at the end also, you can have any combination of A's and B's. So as we are designing deterministic finite automata, so we applied input symbol A on Q naught as well as B. Fine. So if you come to this Q1, we applied B on Q1, but not A. So now you need to apply A. So here, if you take A as self loop, then you will get string as B. So which is not the right one. So instead of applying this A as self loop on Q1, we are moving that to Q naught. So that here we'll get A, B, again moves to B. So starting with A, B, then move in this direction. So that is B, A, B. So check if we have this BB as substring. So you can see BB as substring. So this is accepted. Now come to Q2. So on Q2 we applied input symbol A. So now we need to apply B also. So check whether we can put it as a self loop. So on Q2, if you place this B as self loop, you'll get input symbol as A, B, then B, and you can have any number of B's, B. Yes, that is also accepted. You'll get something like this, B, B. So here this is a substring, so this is accepted. Now move to this Q3. So on Q3, we applied input symbol A, and on Q3 again we need to apply input symbol B also. So check if whether we can apply this B as self loop or not. So if you apply that, you will get a different sequence, which is not possible. So you won't get this BB as substring in this case. So instead of taking this as self loop, we are moving it to the previous state. Then we'll get this possibility. AB, ABA. So again, if you check this, there is no sequence BB. There is no substring like this. So we can't use this sequence. Now, if you go from, if the automata moves from Q3 to Q1 on input symbol B, then you'll get the string like this. So where you can see this BB as substring. So this is accepted. Now, if you move to Q4, so we already applied input symbol B on Q4. Now we need to apply A also. So we'll check with Q3, Q2, Q1. So as it is not possible with all the cases, we are moving to Q4. So we are moving from Q4 to Q0. So on input symbol A, transition takes place from Q4 to Q0. And this is the final answer. So this complete diagram or this DFA, it accepts all the strings containing BBAAB as substring. So first part was done. Now we need to check the validation part. Validate AAABB. So validation of string. So this is a notation for this. So first we need to take the first input symbol A. So Q naught on A. It can be written as delta of Q naught on A. So Q naught on A is from the transition table or from this diagram Q naught on A, it stays in the same state Q naught. So write it as Q naught. Now take two input symbols AB. So this can be written as delta of Q naught comma A comma B according to this notation. So we'll get delta of Q naught on A is Q naught. Delta of Q naught comma A is Q naught. And write this B as it is. So what is Q naught on B? From the transition table, Q naught on B is Q1. So we got Q1. Now take next symbol also, all first three symbols, ABB. So this can be written as Q naught comma AB, that is the first two symbols, followed by the last one. So Q naught on AB, so we got the answer here, it is Q1. So place Q1 and write this B as it is. So delta of Q1 on B. So Q1 on B move to Q2. So we got Q2. Now find out Q naught on, take first four symbols. So write this first part like this and the last symbol separately. So we got the answer before. Delta star of Q naught comma ABB is Q2. So we got Q2 in this place and write this A as it is. So delta of Q2 on A from the table Q2 on A is Q3. Next take first five symbols and place these four symbols inside, last symbol outside. So this result is Q3 and place the last symbol as it is. So Q3 on A from the transition table is Q4. So write Q4. Now take all these symbols, the complete string. So write all the symbols except the last one inside and last input symbol outside. So this value is Q4 and the last value is B. So check Q4 on B from the transition diagram. Q4 on B is Q5. Now check whether Q5 is a final state or not. Yes, Q5 is a final state. So we can say that the string is a valid string. And this is the diagram. We need to perform minimization. So first from the diagram, we need to construct the transition table. So 1 on input symbol A goes to 6. Then 1 on input symbol B goes to 4. Next, 2 on input symbol A goes to 7. 2 on input symbol B moves to 5. Then 3 on input symbol A is 2. 3 on input symbol B. Here 3 on input symbol B is 8. So in this way, we need to construct this transition table from the diagram. Now find out zero equivalence by placing final states in one set, non-final states in another set. So from the diagram, we have two final states, 1, 2. So place both 1 and 2 in one set and all the remaining states in separate one. That gives you pi naught. Then find out 1 equivalence pi 1. So here we need to check 1 and 2. Input symbols are A and B. So check 1 on A, 2 on A, 1 on B, 2 on B, transitions. So 1 on input symbol A from the table is 6. 2 on A is 7. So we got 6, 7. Then 1 on B, 2 on B. So 1 on input symbol B is 4. 2 on input symbol B is 5. Yes. Now we need to check this complete part. So check if both states are present in the same set or not. So here from pi naught, you can check that. So 6 and 7, both are present in the same set. So we can say that both the states are equivalent. And also this one, 4 and 5. 4 and 5 are present in same set, so they are equivalent. So we can say that 1 is equivalent to 2. Now come to the second set. Check 3 with 4, 3 with 5, 3 with 6, 3 with 7, and 3 with 8. So if you check 3 with 4, take 3 on A, 4 on A, 3 on B, 4 on B. So 3 on A is 2, 4 on A is 1. So this is 2, 1. 3 on B, 8, 4 on B, 8. Yes. So check if 2 and 1 both are present in the same set or not. Yes, both are present in same set. So they are equivalent. And as both the states are same, no need to check them separately. So we can say that 3 is equivalent to 4. Now check the second sequence, 3, 5. So here from the transition table, we got 3, A as 2, 5 on A, 2. 3 on B, 8, 5 on B, 6. So as they are same, no need to check. And here you need to check 8 and 6. 8 and 6 both are present in same set. So we can say that 3 is equivalent to 5. And the next pair is 3 on 6. So 3 on 6, we got A values as 2, 3, B values as 8, 1. So check if 2 and 3 are present in same set. So here 2 is present in different one and 3 in a different one. So no need to go to the second part. So from this we can say that 3 is not equivalent to 6. Now next combination is 3, 7. So 3 on A, 2, 5, 7 on A, 5. Sorry, 3 on A, 2, 7 on A, 5. 3 on B, 8, 7 on B, 2. So 2 and 5, they are not in same set because 2 is final state and 5 is non-final state. Similarly, A and 2 not present in same set. So both of them are. So we can say that 3, 7 is not equivalent. And check the next combination 3, 8, the last combination in the set. So we got the values from the transition table like this. So again, 2 is final state and 4 is non-final. So we can directly say 3 is not equivalent to 8. Now we got pi 1 as, so write 1, 2 as it is because 1 is equivalent to 2. And here you need to write 3, 4, 3, 5. So 3, 4 and 5 in same set because they are equivalent. Whereas 6 is not equivalent to 3, 7 is not equivalent to 3 and 8 is not equivalent to 3. So you need to remove them from the previous set and place all the 3 in a separate set. And from this, after that you need to find out 2 equivalents. Now you need to check 6, 7 and 6, 8. Similarly 3, 4, 3, 5. So if you take 6, 7 from the transition table, we got 3, 5 values. So you need to check these values from pi 1 but not from pi naught. So 3, 5 both are present in same set. Then 1 and 2, they are present in same set. So we can say 6 is equivalent to 7. Then 6, 8, we got 3, 4, 1, 2. So 3, 4, you can see from pi 1, 3, 4 are present in same set. Whereas 1 and 2, again 1 and 2 are also present in same set. So we can say 6 is equivalent to 8. Now check 3, 4. So these are the values. 2, 1, again 1 and 2 present in same set. 8 and 8, they are identical. So we can say 3 is equivalent to 4. Then check 3, 5. 3, 5. This combination. So we got 2, 2, 8, 6. So these two states are identical. Now 8 and 6. 8 and 6 are present in same set. So they are also equivalent. So we can say 3 is equivalent to 5. That's it. We completed everything now. All the combinations. So we can write pi 2 as 1 comma 2. So as all of them are equivalent, the states remain as it is. No need to place them in separate set, just like how we did before in case of one equivalence. Now you can observe this pi 2 is equivalent to pi 1. So there is no change in states. So we can stop the process here, and these are the states. So we got total 3 states. Initially, if you observe this, we have total 8 states. Now they were reduced to 3 states. And this is the minimized DFA. And the third question is construct NFA for the regular expression. So this we are doing using, so this conversion from finite automata to regular expression is done with, here we are using subset method in order to convert the given finite or given regular expression to finite automata. Here we are using subset method to convert the given regular expression to finite automata. So take the expression, and these are the notations. A plus B can be represented in this way. A into B notation, and this is the A star notation. So first take 0 plus 1. So this is in the form of A plus B. So the notation will be like this. In place of A and B, we need to place 0 and 1. Now we got 1, 1 whole star, which is in the form of A star. So as there is single input symbol A here, we wrote only single value. Whereas here we got two input symbols. So notation will be like this, 1, 1 whole star. So we need to take two input symbols and change the representation. Then we need to add the result with 0. So again, this is addition. Now we need to multiply 0 plus 1 into 1, 1 whole star. So we got 0 plus 1, 1, 1 whole star, multiply both of them. And what is the notation for multiplication? This one. A and B should be multiplied. So in between there should be epsilon, and this representation is for 0 plus 1, that is A, and the second part is for B, which is 1, 1 whole star. So now we did this first part. So you need to add this result with 0 using this first notation A plus B. So let us add that. So this complete part is considered as A. This complete part, it should be added with B. Okay. So we are just in place of A, here we place 0. Here in place of 1, in place of B, we placed 1. In the same way, this complete result, it should be taken as A, and this second part should be represented as B. So apply whole star on this. That is the third notation. So if you apply whole star, then you'll get result like this. So the question is, convert the given DFA into regular expression using Arden's theorem. First step is we need to construct equations from the DFA. So here first one, that is 1 equal to, you need to check the incoming edges. It is receiving incoming edge, or it is 1 is having incoming edge from 3. And the input is A. So it should be written as 3A. As this is the initial state, we need to add epsilon to 1. Then coming to second one, 2. It is having incoming edge from 1. So it should be 1A plus 1B. And it is having self loop. So it should be written as 2A. It is receiving input from 3. So it should be written as 3B. And 3 is having incoming edge from 2. Input is B. So it is 2B. So after writing all these three, so you can see there are two final states. So we need to find out 1 union 3, which gives you the final regular expression. So let us take the first equation. We need to solve both 1 and 3. So first equation is 3A plus epsilon. In place of 3, we need to replace this 2b. So that will get this equation. Now take the second one. So second one is 2a plus, take 1 common and it will be represented as 1 into a plus b. And here 3b means in place of 3 we need to write 2b. So if you write 2b in place of 3, you will get 2bb. Now from this again, if you take 2 common from 2a and 2bb, you will get 2 of a plus bb and write this 1 of a plus b as it is. Okay. So you can see that this is in the form of r equal to q plus rp. So this is r, this is q, r, p. So according to Arden's theorem, when we have the equation in the form of r equal to q plus rp, then it should be written as r equal to qp star. So you will get the equation as 2 equal to this one q and a plus bb whole star. So we got the equation as 1 into a plus b into a plus bb whole star. This is in the form of r equal to qp star. Now we need to solve this equation 1. So what is the value of equation 1 here? It is 2ba plus epsilon. So in place of 2, we need to place this value, this complete value. So you will get this and then write this ba plus epsilon as it is. So we have ba plus epsilon. So we wrote the same thing here again. And you can see that this is in the form of r equal to q plus rp again. So this is rp. So you can see this is r and here one is r. The rest of the part becomes p and this epsilon becomes q. So for better understanding, the same equation was written in this way. So when we have the equation in the form of r equal to q plus rp, we need to write it as r equal to qp star. So what is q in this case? Epsilon. So epsilon into p star. This is r and the rest of the equation is p. So it should be written as p star. So place whole star. Okay, this is in the form of qp star now. So what is second equation? 2 equal to 2a plus 1a plus 1b plus 3b. So here in place of 1, we need to place 3a plus epsilon. So that is our original equation. Plus, again here in place of 1, we need to place 3a plus epsilon and write the remaining equation as it is. So we got the value like this. And now you need to take 3 common and write AA plus AB plus B within this brackets and A plus B as it is, this A and B. After this, again this equation, it can be written like this. Now you can see this is in the form of R equal to this R, P, and this complete one becomes Q. R equal to Q plus R, P. So it should be written as R equal to QP star. So Q means this complete value. So we took this complete value. P star means P is only A. So that becomes A star. Okay, we got the second equation. Now we need to solve third one. So third one is 3 equal to 2b. So take 3 equal to 2. Second equation is this value. So write this completely and write b outside. Then we need to expand it. So multiply this whole value with B and we got this result. Now again, you need to arrange this in this form. So you can see that we got the value as A star B plus BA star. So we wrote this as it is here and we place this one towards right side. So you can see this is in the form of R equal to Q plus RP. So R, this complete value become Q and here this 3 become R. Rest of the part becomes P. Okay. So Q means this one. So right, this is Q. P value is A star B into that complete one and place whole star. So now you got 1 as well as 3. So if you take union of both of them, we'll get the final result. So take this one equation and this complete one. So this is the final regular expression for the given DFA.